Hello, everyone. Welcome to Munro Live. I'm Tom Pruchet from Munro and Associates, the Director of Electrification. I'm here today with Dale Koch. Is that the right way? Cook.
It's
okay,
good.
Very good. Dale is with 3IS, who is a partner company of Munro and Associates. They do a lot of our electronic deep dive work, and we're going to show you some of the results of those deep dives on the Cybertruck here today. So the topic of discussion is 48 volts. It's all the rage. It's a brand new thing. For me, it's kind of what's old is new again, because back in the late 1990s, early 2000s, we had 42 volts, and it didn't go over well at all. Very few systems converted to that, but we're going to do 48 volts and find out if it's going to stick to the wall this time. So maybe I can start with that. Dale, what do you think? Tesla did a pretty good job integrating 48 volts, so it seems on the surface there's lots of blue connectors, and that's how we know with clarity whether it's a low voltage or high voltage connection. So did they integrate enough of the 48 volts this time to inspire others to follow their lead?
I think there's a good chance, and from a European perspective, 48 volts has been around for mild hybrids for quite a while. But basically, it's been used as the 48 volt alternator. They've got a stalternator, I call them. It's a starter alternator that runs off of 48 volts. You got a 48 volt battery, and usually that's a rather closed system. It's those two, and from the 48, they have a DC to DC converter that steps it down to 12 volts to charge up the 12 volts and operate all the 12 volt components on the car. What Tesla did with 48 volts is they took a lot of their big loads, things like the radiator fans, the cooling fans, the power steering motors, and there's 3 of these motors, same fundamental core of the motor, just different connections. Some of them use a belt drive, some of them use direct drive to the worm gear on the steering, or the pinion on the steering. And, we say it's a 48 volt system, but there's still 12 volt components on the car. You still got some historical modules that Tesla didn't do the investment to convert them to 48 volts, because I think the suppliers basically said, this is a commodity. We're not going to make that conversion unless you pay us.
Yeah,
yearly.
I'm sure if they're going to pay, they've got to have a business case to do so.
Exactly.
And that could be anything from reducing material costs through less copper, if and where that actually happens. And then it could also be efficiency, which would play into how often does this thing get used.
Exactly.
A seat motor, once every blue moon.
Guess what? There's still 12 volts.
How about that? So at least some logic and reason was applied to this.
They did take the window lift motor. They've got a supplier, Broza, took and redesigned their system. They redesigned the motor to operate off of 48 volts. So that's a 48 volt motor. Then we've got our controllers, and these are the 2 main front controllers. There's a left and right. This circuitry here is basically a switching circuit that can convert 16 volts to 48 volts, and it's bidirectional. It can put power towards charging the battery or towards the vehicle, whichever way it wants to run. And this also, if I've got the right controller, the left controller has the jump start post that comes into it. And the jump start post is isolated from the battery. All that, if you connect up to jump, it figures out what voltage you're using, and you can use 12, 16, or 48. And it then says, okay, we're going to use that to get the car up and running again. So it powers up the rest. This will create the 48 volts from that input and wake up the rest of the car, because the 48 volt battery in this case is dead. So they don't have any reference to work with, and the DC to DC doesn't light up the car. You've got to go through a jump in this case. So that takes care of that. It talks to the right body, or the right body. Left talks to the right talks to the rear, and the rear goes to the DC to DC converter that's in the back, that's in the penthouse.
So the 48 volt battery, for example, we've seen lithium ion batteries as low voltage batteries before, but it's the first time we've seen one at 48 volts.
Correct.
And it's really small.
It is.
Look at
it's a compact little battery.
Right. And just, what was it, 4 amp hours? I can't remember what you
Yeah,
said.
I think it's a 4. I think you're right.
Yeah.
Um,
But when you do the math on that, that was what surprised me, is that it actually has quite a bit more watt hours than the 12 volt one that this replaced.
Yeah.
So,
and
part of the magic of 48 volts.
and everybody talks about taking the step from 12 to 48. Tesla did an intermediary. They've got an intermediate step. If you go back to the Plaid, this battery is a 16 volt battery. So fundamentally, from that system, it's a step of 3, not a step of 4. But you go to a conventional vehicle, any ICE vehicle, it's a 12 volt system, so it's a step of 4. And the other cool thing is the connector for the battery is a unique connector for Tesla. It's designed specifically for this battery. There's communication in the second center portion, and you got the positive and negative terminal for the battery. So when this, and you watch, I'll put it on wrong the first time. When this goes down, it locks in place, but the battery is still off. It's not sending power down the wire. You have to lock the connector position assurance, which is what we, in the industry, we call it a CPA. For Tesla, we've kind of coined it's an eCPA, because it has a little shorting bar in here that makes a connection and tells the battery it is connected correctly to the vehicle. So if somebody wants to shut their Cybertruck down, you go to the center screen, you select their menu set, select power down, you go to this battery, and you watch, I won't be able to do it, but you release the CPA and the car's dead. It shuts off the high voltage, 48 volt, nothing is running.
Poor man's kill switch.
It is a kill switch, and it saves you from having to pull the post off the battery. Anytime you want to do repairs on your car, you want to pull the negative and hide it someplace so that it doesn't reconnect while you're playing with the other electronics.
Very cool. And of course, the 48 volts is critically involved with the powering up of the high voltage battery, because
Correct.
you don't have power to turn on the contactors without
Exactly.
it. So yeah. Really
And
good
as you said, any connector that has 48 volts in it they've gone with either the baby blue housing or shroud for the connector, or they'll put a baby blue piece of tape on the connector to tell you that that's 48 volts.
So,
and it's not harmful. It's in that semi-safe zone, but you don't want to touch it. It can hit you in the back of the elbow a little bit, so to speak.
So when we had 42 volts back in the day, that represented what was a logical combination of 3 lead acid batteries in series, but that doesn't add up to 42 volts unless you consider how you charge them.
Yeah.
And then suddenly it does make sense. That's why.
Yeah, same thing. Same thing with this is you go up above 50 volts to really charge the battery, and they have a pulsing system or pulsing technique that they use to do the charging. It's quite interesting. We've done some work looking at the Ethernet, or the Etherloop as Tesla calls it, and have learned a few things about that, in that we were able to connect in and kind of snoop a little bit with one of our partner companies. And from that standpoint, we worked with Intrepid and used their equipment, and were able to tap in between the rear controller and the left front controller, that Ethernet cable. We basically shut the car down, so it was null and void or inert, put our connections in, and they have a way that it takes the packets and it makes it look like there's nothing there. An incoming packet on the one side gets received and replicated on the other side, and the same thing the opposite way. So fundamentally, the car has no idea that there's something in series there, or that there's somebody monitoring. It just sits there and looks at the messaging.
So it's a sort of bridge device.
It is a bridge. Yes,
where
exactly.
Normally you'd have a node sitting there on a bus, but now we've kind of separated the bus to a gazinta and a kamzada.
Right. It handles all that traffic. So as far as the two controllers are concerned, there's a slight delay in the message, but not enough to cause alarm, if you would.
So our creative thinking users online may be thinking, oh, a bridge device. I could put software between there and do really magical things. And,
yeah, well, I wish them great luck on that. The protocol is a little more complicated than that. And we have not broken down that protocol. We know that there's audio signals, there's control signals, but when it comes down to, for example, controlling the steering motor, this motor's not on Ethernet. That motor's on CAN, and it's a redundant CAN because we want to make sure from a safety standpoint, ISO 26262, we want to make sure that if there is a single point failure, it still works. So redundant power supply and redundant communication and redundant steering angle sensors between the various devices.
Nice. So 42 volts didn't work because there weren't enough of these components that were developed.
Well, and back then you were still using relay switching, right? The solid state control was still learning. You know, the semiconductor companies didn't know what the auto industry wanted, and now for this module there are 48 volt drivers, 48 volt motor drivers. They're readily available. You can go to the, DigiKey, look it up. I'm not marketing DigiKey, but you can look up the part and buy them off the shelf. I
look at this thing.
Yes.
And it's kind of reminds me of the old one.
Because it is.
It looks the same, but we know it runs
at 48 volts.
So that makes me believe that inside it's like the old one. It's a brush type DC motor, kind
Correct.
of old school, just wound differently for 48 volts.
It's finer magnet wire.
Yep. So that said, 48 volts was also an opportunity to upgrade the technology for those more power consuming devices. A window
Correct.
lift doesn't happen all that often, but something like steering.
Well, the steering is an obvious one because you go from instead of a 4 gauge wire feeding power, you're down to an 8 gauge, or even it may even be a 10 gauge. So your diameter of wire is reduced, the amount of copper is reduced, and you end up with a fundamentally more efficient system because I'm not running heavy copper everywhere. And I am a firm believer, if I can take weight out of the copper, it's a good thing. Because fundamentally, by going the higher voltage, your current gets cut either to a quarter or a third, depending on where you're starting from.
But I'm going to guess they went well beyond what was the case here, where you just simply did the same thing at a different voltage. Is this a 3-phase AC motor? Or?
It's a dual wound 3-phase motor. Yes.
So again, the opportunity to advance the state of the art and give it some modern aspects.
When you look at this portion of the motor, the guts, if you will, are the same between the 4 motors, 48 volt motors. It's from there to there. What changes is the connection here. And for some reason, they have 3 different circuit boards for that. Now, they also knew, and this has been talked about, they knew that Sandy was going to tear this truck apart. So this happens to be the circuit board. I'll try and get it out of the bag here. That has on it, as soon as I find it, right there we go. Right there, it says, "Hi, Sandy."
Like we needed something more to feed his ego.
Yeah, well, we're not going to go there. But so fundamentally, that was Tesla's Easter egg that they dropped here, and there's a number of them elsewhere.
Well, we've talked about most of these components, yet we have this whole slew of other ones in the back here. Any of them that jump out at you to?
This one in particular, that's the PCS2, which is the power conversion module. That does the AC to DC. It creates it's a dual 48 volt. It has the capability of bringing the charge port comes in, and it can take and can do whatever conversion is necessary to charge the batteries. And it is state of the art. That we have a very detailed analysis of that module and can tell you how these big ferrites and what they do, and fundamentally a lot of how the module works. We've got that broken down in one of our reports. But that is, it uses planar transformers, and
which is a way to make a transformer really short,
really thin. But fundamentally, you got the ferrite cores, and the circuit board are the windings of the transformer. So it's, like I said, very really advanced technology. This may have been something, and I'm speculating, that came down from SpaceX to the car company, because this is the type of thing you'd put in as far as rocket tech, it's rocket science.
Nice.
And then the hardware 4 that I think is going to be one of the future episode, going through that. There is a trailer controller that had to be added, because when you have a 48 volt system, the trailer runs off 12 volts. The lights are all 12 volt bulbs or 12 volt LEDs. You got a 12 volt battery system. So you need to create that voltage. So a whole separate module was created just to manage that 4-pin and 7-pin connector for your trailers.
So we probably don't have the time to go through what all the components are.
Oh gosh, no.
Volts. But there's a couple of key ones that seem like low-hanging fruit. Did they change the fans to 48 volts?
Yes, they did.
They did.
The rad fans and the HVAC blower are 48 volts, BLDC, basically brushless DC motors. And those are all controlled. The control is in the modules. It's not local on the board, in the fan. It's a 4-wire going to that device, all twisted, with a ground trace running through the middle of it to drive those motors.
Interesting.
And that's historical. Tesla has done that for a long time.
It's got a big compressor motor for the air suspension. Is that one 48, do you recall?
I think that one's still 12 or 16.
Okay.
And again, you got me. I told you to stump me, and you managed to. That's one we have not tested it yet, but we are going through and we're running tests on all of the motors. We're tearing them apart down to their base motor, and we're going to be creating a report that basically documents all the dimensions of the motor, the RPM of the motor based on the voltage, and come up with the torque of the motor from a measurement standpoint. So that's something else we're doing. That's all of the somebody's interested in the small motors, we're going to have that.
Okay. Now, did they do anything in inverse? Meaning, okay, the high voltage battery went from 400 to 800 volts. That would mean a lot of other components had to go to 800 volts, but they might have decided that they could have gone to 48 for some. An AC compressor comes to mind.
Way too much current.
Okay, so it's still
that's still running off the high voltage rail, because off of even 48 volts, you'd be running a pretty large gauge wire to it, because it's a high current device.
Which means they had to do some development there, probably, unless they were off the shelf.
It may be off the shelf because there are 800 volt systems out there, but it's a altogether different circuit board design on it for the control. It's a 800 volt 3-phase motor system on it, and because of the size with the cabin and everything else, I think they upgraded the capability on it.
Well, there you have it. We know that there was no real practical way to convert everything that was 12/16 volts to 48, but they seem to take a somewhat intelligent approach to which ones they did convert. Are there any that you thought they should have that they didn't?
Honestly, no. I look at it, and the bang for the buck I don't think is there. The where you would save if more of them were converted to 48 is, like a door lock or a latch release. Those are still the lower voltage because there's no volume in it yet. If you look at, window lift motor, they build millions of these. It took some convincing to get Broza to make a 48 volt version of this for them. And it's a very modular design. I can spend an hour talking just about this from that standpoint of what they've put into it. But, fundamentally, if you look at the system, on the Plaid, the doors were controlled by the left and right body controllers. And it made a great deal of sense. When they got to the Cybertruck, the doors have a separate module in each door. Now, why would you disintegrate that when you had it integrated into the big controller? Why would you separate that? And I'll leave that for another episode to tell you the why. I can tell you the how, but the why is what's important. And there were some interesting things about that we found in our analysis. So feel free to send questions.
There you go. And if you're a technician and you stumble across one of these fancy blue connectors, now you know what that means. And if you take a look on the board back here, there's no shortage of blue connectors in this vehicle.
No.
So
there's quite a few.
So, with a little luck, knock some wood, everyone will follow Tesla's lead, and this time 48 volts will stick to the wall.
I think it gives you the opportunity to save some copper. And when all's said and done, weight is king when you talk about an electric vehicle.
And we've got all these mild hybrids out there, and suddenly they're popular, right? And a lot of them are 48 volts, yet they have these redundant 12-volt systems, and there's an opportunity there to integrate the two together, and we'll see if that happens.
And it's a matter of switching power supplies are common now. And so all of these use basically switching supplies to take the 48 down to the 16, down to the 12, down to 12, down to 10.5, down to 5. And then there's, for some of the lower voltages, there are linear regulators on the modules. So they took a lot of heat out of these boxes because the devices aren't pumping as much current.
All right. Well, I'm going to close up with a thank you to Intrepid Controls for providing some wonderful hardware for us to work with here.
That was really cool.
They set us up with their RAD Gigastar and their RAD IO2, which were amazing tools for automotive engineering, and especially for the Ethernet part of it, which is a relatively new element to our automotive engineering.
And there are cases where people have tried to break in and they had a little problem. The mothership got angry.
Yeah, always beware of the mothership.
But anyway.
Well, thank you, Dale.
You're welcome.
Much appreciated.
Pleasure. Tom, thank you.
Where can people find the reports?
Oh, thank you. You can find our reports online, and you can contact the sales department if you want details or permutations or have any special requests for data that might be associated with the 48 volt system or any other system that's part of the Cybertruck.
Oh, exactly. We can now break up the report. I have to be careful. My colleague's going to be angry with me. But we can break up the report and customize it a little bit for what your questions may be.
There we go.